Hello everyone. Today we're going to talk about functions and mathematical models in chapter 2, section 3. So we're going to talk about two things. We're going to talk about functions and then the applications of mathematics in modeling. When we talk about the mathematical models, we mean we apply mathematical theories to real problems. So there are some procedures to solve a real problem. So suppose you have a real-world problem, then you need to formulate the problem because the problem itself doesn't tell you anything about the equations or any math expressions. So we need to formulate the problem and set up some equations to solve. And we call that a mathematical model. And then we just solve this model and obtain some solution about this model. But that's not the end. We still need to interpret the solution to make sure it makes sense, to make sure it's the real solution of the problem. So usually you will not get the exact solution or a good solution for the real problem. You still need to test it. And if there's any discrepancy with the real world problem, then you need to modify the model and do the whole process again to modify the model, the equations, and solve it again. And this whole cycle just repeats several times or even many times until you get a solution that you are satisfied. So that's the process of mathematical modeling. Okay, let's talk about a few more simple functions. We use different functions in the mathematical modeling. We have some basic types of functions such as polynomials or rational functions and power functions. And usually we have to use all of them in combination in any real world problem. So what is a polynomial function? A polynomial function is a function like f of x equal to 2x to the 5 minus 3x to the 4th and plus half x cubed plus square root 2x squared minus 6. So this is the finite sum of terms with positive integer powers of the variable. So that's the polynomial. And if you divide two polynomials, you get a rational function like capital F of x equals 2x cubed plus x minus 1 over x squared plus 3. So that's typical rational function. And the power function essentially is a function with some power in the variable x. Like g of x equals x to negative 3/2. Okay, but as I said, usually you need to combine all of those functions to model a real problem. Okay, so one of the important applications in real problems is the economic models. Since this is a course for applications of calculus in economics, finance, and managerial or life sciences, so it's important to discuss economic models. When we talk about economics, okay, we are basically talking about price, revenue, cost, profit, those quantities. And there are two types of curves we are discussing here. One is called the demand curve and the other is called the supply curve. Both curves are prices as functions of the quantity in the market. Okay, so in the two diagrams or two graphs, you're going to see two different curves. The x-axis is the quantity, and the y-axis or vertical axis is the unit price of the commodity. The demand curve is on the standpoint of the customer. Okay, so the customer wants the price goes down as the quantity increases. Okay, so you see a decreasing function. On the other hand, the supply curve or supply function is on the standpoint of the sellers. So they want to make more money from the commodity. So they want the price goes up even when the quantity increases. So if you want to make a deal between the customer and the seller, then they have to make a equilibrium, and we call that market equilibrium. So that happens when the demand curve and the supply curve meets at the point of x naught, y naught. So we call this x naught the equilibrium quantity and the y naught, which is the price, the equilibrium price. Okay, so let's just do a simple example of using mathematical modeling to find the market equilibrium. So suppose the demand function of a commodity is given by the function of P equals negative 0.025x squared minus 0.5x plus 60. And the supply function is given by P equals 0.2x squared plus 0.6x plus 20. And we need to find the market equilibrium. As I said, the demand function or demand curve is the price as a function of quantity, demand, and the supply function is the price as a function of the supply. Okay, so P is the price and X is the quantity. So to find the market equilibrium, we need to set these two prices equal. That's how the deal is made, and solve for X from this equation. So we got the negative 0.025x squared minus 0.5x plus 60 equals 0.02x squared plus 0.6x plus 20. And this is a quadratic equation, can be easily solved. So the first thing you do is move the terms to one side and combine like terms. Okay, so we just move all the terms on the right to the left and change the sign. So what we get is negative 0.025x squared minus 0.5x plus 60 minus 0.02x squared minus 0.6x minus 20 equal to 0. So all the terms becomes negative if we move from right to the left. And then we combine like terms, we get negative 0.54x squared minus 0.11x plus 40 equal to 0. We got some fractions that are not convenient to deal with. So we want to make all the coefficients to be positive and the integer. So what we do is just divide by some small number. Like in this example, we can divide all the terms on the left by negative 0.005. Okay, if you do that, then you're going to get the equation of 9x squared plus 220x minus 8,000 And then you can factor the left-hand side to get 9x plus 40 times x minus 20 equals 0. And to solve this equation, you just simply set each factor to 0 and solve each linear equation. So we got 9x plus 40 equals 0 and x minus 20 equals 0. So we got two solutions. X equals negative 40 over 9. But remember, x is the quantity of the commodity in the market. So that's not realistic. You cannot get the negative number for the quantity. So we just discard this solution. And then we get the other solution, x equals 20, and this is the real solution. So that's the quantity in the market at the equilibrium. Okay, to get the price of the commodity, we just plug back 20 for x in the either the supply function or demand function, and we get 40. So that's the price at the equilibrium point or market equilibrium. All right, this is the end of today. We're going to discuss 2.4 next time.